All right, hello. Today we are going to be talking about dictionaries. So through this unit and the previous unit, we've been learning a lot about data structures, primarily about lists. And lists are super duper useful. There are, however, a few use cases where they aren't the best choice. There are other data structures that might be better. So for example, let's say I want to remember the ratings that I've given to a bunch of restaurants. Let's look at some examples using what we already know, and then let's try and see if we can learn something new to make it even better. So what if I store each restaurant and rating pair in a tuple and store all those tuples inside of a list? So I've got my list of ratings. I've got my restaurant number 1, it's going to be Chili's with 1 star. Restaurant 2 is Panda Express with 3 stars. Each of those is a tuple. I can append those 2 tuples to my overall ratings list, and then that works. But what if I have a huge list of ratings and I want to find a specific rating in that list? I have to look through each of the ratings in my list of ratings and check, is index 0 of that rating equal to the restaurant I'm looking for? And if it's not, I have to look at the next one and the next one. What if the one I'm looking for is at the very end of my list? Like, this solution works, but it feels kind of clunky and it's really cumbersome. It takes a lot of extra effort to find a restaurant's rating with that restaurant's name. It takes a lot of extra effort. So let's look at attempt number 2. Let's say I make 2 lists to act in parallel here. I have a list for the names of the restaurants and a list for the number of stars. And at any given index, that one index is going to refer to a single rating. The index in the restaurants list is going to be the name. The index in the stars list is going to be the rating for that restaurant. So I'm going to append Applebee's to my restaurants and 2 to my stars. So index 0 in both lists is going to be that rating. I'm going to append Red Robin to my restaurants and 4 to my stars. Index 1 in both lists is going to be that rating. And here, it's a little bit easier to find a specific restaurant's rating. I can call the find function on my list of restaurants with the name I'm looking for, save that index, and then I can grab out of that restaurants list at that index and that stars list at that index to find how many stars that restaurant has. So this works more smoothly than the previous option, but each time I want to add a new rating to my program, I need 2 more lines of code. And it's still a little bit finicky to grab a specific restaurant's rating. Like, what if that restaurant doesn't exist? What are we going to do? So let's look at a new data structure, dictionaries, because both of those were a little bit terrible. They work, but they could be better. Fortunately, there is a better way, and that way is using dictionaries. So dictionaries store values in a similar way to how lists store them, but instead of using indices to show where values are stored, dictionaries use a thing called keys. And the big difference between an index and a key is that a key can be of any data type, as long as that data type is immutable. That means we can use strings, integers, floats, or even tuples as a key in a dictionary. So let's see how that looks in our restaurant rating example. So I'm going to make my dictionary of ratings. And I can see it's a dictionary because I'm using this new symbol. I'm using curly braces instead of these square brackets we used for a list or parentheses we used for a tuple. I'm going to say my ratings dictionary at the key Pyology equals the number 5. My ratings dictionary at the key In and Out also equals the number 5. And now if I want to find the rating of a specific restaurant, if I have that restaurant's name, I can say that restaurant's name has my dictionary of ratings at that name number of stars. So our keys are the names of the restaurants, and the values at those keys are the number of stars associated with that restaurant. So if I want to make a dictionary that already has values inside of it, I can do something like this. I can make my dictionary equal, and then I have my curly braces, and then I'm going to have my key value, a colon, and then the value associated with that key. So key, colon, value. So I have a key value pair, and I can separate my key value pairs with commas, and I can have as many keys and values as I want in a single dictionary. In this example, both the key and the value are strings, but like I said before, the key can be any type as long as that type is immutable. So my key could be a float, it could be a tuple, it could be an integer even. I could have a dictionary with integers as my keys, and that would look kind of like a list, but my keys don't have to be in increasing order here. I can have my keys be whatever numbers I want. The values inside of a dictionary can be whatever type I desire. I could have a dictionary of strings, a dictionary of integers, I could have a dictionary of lists. I could have a dictionary of more dictionaries if I wanted to. The possibilities are endless. And adding a new value to a dictionary is super easy. You don't need to call a function. Unlike lists, which use the append function, dictionaries, you just have to say the name of your dictionary at a new key has the value associated with that key. So here I'm saying my dictionary at the key 13 1/4 equals value 3. Another nice thing about dictionaries is that you are allowed to mix and match the types of your keys. They don't all have to be the same type. It makes the most sense to be consistent with what types your keys are, but they don't have to be the same type. So there's two big things to know about keys when we're using dictionaries. Number one, you're not allowed to have duplicate keys. Just like in a list where each value has one index and there can only be one of each index in a given list, you can't have more than one of a given key in a dictionary. If you try to add another entry with the same key as one that already exists, it's just going to overwrite the previous value at that key. Secondly, you are not allowed to access a dictionary at a key that hasn't been put into the dictionary. Just like in a list, if you try to grab from an index that is too big, bigger than the length of your list, grabbing from the dictionary at a key that doesn't exist will give you a key error. So there are two ways to avoid key errors, and here they are. Number one, we can use an if statement to check if that key is in our dictionary. We can use our in keyword again. So if the key we're looking for is in our dictionary, we can do whatever processing we want with it. We can print it, we can do a calculation, however we want to do it. We can print my dictionary at that key. If our key was not in the dictionary, in the else, we can just print that key was not a key in the dictionary. Easy. We can also use a try and except here. I can try to print my dictionary at that key, or do some calculation with it, or whatever I want to do. And then if this access fails, if I don't have this key in this dictionary, we're not going to call this print. We're going to jump into the except with this key error, and we're going to print this instead. We're going to print that that key is not a key in the dictionary. And what is going to happen if I print out a dictionary? It's going to look a lot like what it looked like when I declared a dictionary manually. I'm going to see the curly braces. I'm going to see my key value pairs with the colon in between the key and the value. And each key value pair is going to be separated by a comma. Pretty simple. And lastly, if I want to loop over a dictionary, I need to use the for each piece in a larger thing type of for loop. And that's going to give us a new key each time through the loop, which I like to use the key name for this variable because it just makes it make sense. So we can say for each key in my dictionary, my key, I can print just that key value, and my value at that key is going to be my dictionary square bracket key. So whatever is at that key in the dictionary, we're going to print it here in that value slot. And that is just about all you need to know for our lesson today.